In this lesson, we'll conclude a review of Reading Test 7, Section 1. We're now on the fifth and final passage, and here is the reference information. This passage is adapted from Brian Greene, How the Higgs Boson Was Found, published in 2013 by Smithsonian Institution. The Higgs boson is an elementary particle associated with the Higgs field. Experiments conducted in 2012 to 2013 tentatively confirmed the existence of the Higgs boson and thus the Higgs field. This is a science passage. And remember, there are two science passages. This is more of what I call hard science because it's a little bit more technical. In the beginning, it described what Higgs was doing when he put forth this theory to understand the basic physical feature of mass. And then it talked about there was really this puzzle, the physicists in the 1960s, and it describes, here's the puzzle. Physicists knew that the particles did have mass, but when they modified the equations to account for this, the mathematical harmony was spoiled. The equations became complex and unwieldy and were still inconsistent. And so then it talked about Higgs had this theory, but it wasn't accepted at all by the scientific community. But over time, gradually, it gained acceptance, and it was so strong, it was actually accepted before it was scientifically proven, which is very unusual in science because it's always data-driven. So let's take a look at the first question. There's also a graph relating to this passage. Question 42. Over the course of the passage, the main focus shifts from, this is a general question, and you could return, we're just going to do this in order, but in the beginning it described what the Higgs field was and his theory, but then the rest of the passage talked about how it was accepted by the community, how it wasn't accepted, but then finally it was. And so the answer here is, looks like C, right? Explanation of the Higgs field, to the discussion of the response to the Higgs theory by the scientific community. So definitely C for that one. Let's take a look at 43. The main purpose of the analogy of the ping pong ball in line 40 is to do what? So this is what I call a function question. What is the purpose of providing this analogy? So let's take a look at line 40. This is, let's see. All right, so here, for a mental toehold, so that's sort of a way to grasp mentally. This is when they're describing this scientific experiment. Think of a ping pong ball submerged in water. When you push on the ping pong ball, it will feel much more massive than it does outside of water. Its interaction with the watery environment has the effect of endowing it with mass. And so obviously this passage is about mass and the particles, but this is a way to explain it, and he's giving just an example that most people can relate to, right? Ping pong balls. And so what's the purpose of that? Let's take a look at the responses, but it really should be just like an example that most people can relate to. And does it popularize a little known fact, contrast competing theories, that doesn't work at all. Criticize, there's no criticism. It clarifies, right? Explains an abstract concept and giving it more applicable terms that people can relate to because people know what ping pong balls are. So the answer is D. All right, 44 and 45. Remember, we're always going to scan down. We see this is a two-part question. So let's read 44. The author most strongly suggests that the reason the scientific community initially rejected Higgs' idea was that what? And we know that the evidence is bound between 30 and 70. So we're just looking for evidence when it was rejected and why. And so again, you try these on your own, but you're looking for some evidence between 30 and 70 that it was rejected. And so let's take a look here. So it's explaining this was the ping pong ball, and look here, in 1964 Higgs submitted a paper to a prominent physics journal in which he formulated this idea mathematically. So he's presenting the idea here, keyword, it was rejected. Here's the reason, not because it contained a technical error, but because the premise of an invisible something permeating space interacting with particles to provide their mass, well, it all seemed like heaps of overwrought speculation. So that's the reason. It's definitely here between, let's see, 46 and 52, and let's look for the answer. All right, so we definitely think it's C for the evidence, and then what's the answer for 44? It had little empirical basis. Empirical means really based on evidence or can be observed, and it said if you look back, let's just go read this again, where it said it was just overwrought and with speculation. So their stating that it was just based on theory. There wasn't any evidence to confirm it. There was no empirical basis. And so that was a two-part question. It is D and C. And let's do two more and we'll stop this video. So 46 and 47, we noticed this is it's two in a row, another two-part question. So 46, the author notes that one reason Higgs's theory gained acceptance, so now we're shifting to when it gained, we know that's toward the end of the passage, was what? And we want to look for the evidence. Okay, so again, you really want to try these on your own, but we know it's between 36 and 39. It's probably not going to be 36 because the last question we answered, the evidence was in 48, and that was talking about rejecting it. We know the acceptance came later than that, so it's probably going to be one of these last two, right? It's going to be toward the end. So we're going to look around 55 to 83, and we're looking for an evidence as to why it was accepted. All right, so look at 55, but Higgs persevered, so that's after the rejection, and his revived paper appeared later that year in another journal. And physicists who took the time to study the proposal gradually realized that his idea was a stroke of genius, one that allowed them to have their cake and eat it too. In Higgs' scheme, the fundamental equations can retain their pristine form because the dirty work of providing the particles' masses is relegated to the environment. Remember we referenced earlier about this puzzle where it didn't really fit together, and now they're using an expression. So we know here he persevered, and this is when they accepted it because they realized it was a stroke of genius. And they use this sort of vernacular phrase, their cake and eat it too. And you should recognize that also kind of relates to that puzzle because those two ideas really didn't fit together with the particles and the equations. And so the evidence for this one is in 55 to 63, right? When he persevered and they realized it, cake and eat it too. And what's the answer for this one? Let scientists accept two conditions that had previously seemed irreconcilable, right? They didn't fit together, that puzzle, but now they could have their cake and eat it too. And the answer here is A.